Hi, so this is Mr. Max. So recently, I have been doing trigonometry in theme 1 with my advanced subsidiary level learners. So this is the paper that was written nationally last year by the grade 12s, and I'm just going to focus on three questions that deals directly or indirectly with trigonometry. The whole question paper I'm going to work out in such a fashion, okay? Take them topic by topic. So I just want to get to the questions that concern the trigonometry as a sort of a revision for them, okay? I can also make this paper available on my many platforms, but please do support the channel. All right, so I think it's question 8. So question 8 here. So what you have over here is a flexible piece of wire, and this wire is 60 centimeters long. That means from O to A to B, B to O. That is the 60 centimeters. So it is bent to form the outer distance or the perimeter of a sector, as you can see, and the sector of a circle OAB, and the radius of the circle is r. So if that is r, then this distance here will also be r. You agree? Okay, so this distance also will be r here. And another thing also worth noting is the area or the arc length. If you want to find the arc length, and this is given in radians, so your paper also has a sort of formula sheet how you will find the arc length. So when you go to the list of formula and notations, and that is towards the end of the question paper, right, you can find those questions or those formula if you need them. So you see the arc length of a circle is the radians times theta, and theta must be in radians, and so we make sure that the radius times theta, the angle must be in radians. And when you work on your calculator, it will be wise if you can change your calculator from radian mode or from degree mode to radian mode, or make sure it is in radian mode, as you can see like what I have over there. So unfortunately, so if not, you're going to go to the shift and then you set it up, and in degree, if I hit 3, you see there's a D or DG depending on the mode of the calculator you're using. This is now going to tell you effectively that this calculator is in degree mode, and I don't want it to be in degree mode, so I'm going to shift set it up in radian mode, and I hit 4, and now my calculator is in radian mode. All right, so I've got two formula here that I'm definitely going to use. That's the arc length, the one that I've written down, and then there's also the area of a sector, which is a half r square theta. Okay, so let me just go back there, but you should know this formula anyway. All right, so what I have over here, this is the arc length, which is theta r, and now they are saying express theta in terms of r, and we have to show that the area is equal to a is equal to 30r minus r squared. In fact, I'll also write down the area of an arc length, and that is a half, and that was r squared times theta. Okay, right. In other case, let's just work with the information we have. We know that the perimeter is 60. That means the radius plus the radius plus the arc length should give me 60. You need to have a complete equation, right? So from this equation, I have 2r plus theta r equals to 60. We need to make theta the subject of the formula because we are supposed to write everything in terms, express theta in terms of r. So that means we need to get everything over. So this is going to be theta r equals to 60 minus 2r. And now the only thing that is left for us to do is to divide throughout by r. So that is 60 minus 2r. We only divide by r. So now I have written theta in terms of r, and this is what I'm going to use in my other formula. The other formula being the area formula of a sector, and I'm just going to use different color here. So the area of a sector is a half. So theta times r squared, or the other way around. So the area is going to be a half, our theta is going to be replaced by this sentence over here, and we're going to multiply this by r squared. Okay, so anyway, this is going to be 60 minus 2r upon r. Okay, so from here, your algebra should be sound. Remember, if I just have to write it out nicely, this is a half, and this is 60 minus 2r over r, and this is nothing but r times r. So I'm just doing that because I want to cancel out common r's here. So this r and this r cancel. I'm going to be left with a half, and then I have 60 minus 2r times r. Okay, well, it's totally up to you which one you want to multiply first. I will take a half of everything inside. Okay, a half of 60, that is 30. A half of 2, that is just going to be that. Well, if I multiply that by r, eventually I'll be left with, if you multiply out again, so this r should multiply with each term inside the bracket. That gives me 30r minus r squared. And that is what we were required to prove from the information that we were given. Okay, we were supposed to prove that 30r minus r squared, that's giving you the area of that sector. Okay, right, so now that brings me to the second part, and here is where you need to have a little bit of knowledge, because it involves anything that says that r can vary and you need to find the stationary value of something. You need to derive. So we work here with differentiation. Okay, question. All right, so if r can vary, find the stationary value. The stationary value means we take the derivative of the area with respect to the radius, and we should let that equal to 0. So we also know that the area is equal to 30r minus r squared. Okay, so I know that you know from your work on differentiation. Okay, so remember here the power is 1, so you're going to have 1 times 30, that is going to be 30, and so r is going to be taking away 1 from that, and you're going to have 2 times negative 1, and you're going to have that. Well, that should equal to 0. So this basically gives you 30 minus, of course, this is going to be 2r is equal to 0. Now, from here, we can actually now, we have done our first derivative. So from here, you can actually calculate what the value of r will be. So that's minus 2r is equal to minus 30. So r will be 30 divided by 2, that is going to be 15. Therefore, our value of a should be, if we go ahead and substitute, so our area should be 30 times r minus r squared. Of course, we know that our r value is nothing but 15, and we put that in there, and we can use our calculator. Okay, you can say 30 times 15 minus 15 squared, or 15 times 15 is 225. So the final answer is 225. So this is the area, okay, of that sector that is there. But what they are also asking you here is they are saying we need to determine the nature of the roots. Now, in order for you to determine the nature of the roots, you have to determine whether it's a maximum or a minimum. Okay, so what you're going to do is you're going to take the second derivative of that function. So the second derivative of the area with respect to the radius squared, um, with respect to the radius, oh my goodness, let me just write it at a proper place, with respect to the radius square. So if this is greater than 0, if you do the second derivative, then you are dealing with a minimum. Or if the second derivative of the area with respect to the radius square is less than 0, then we have got a maximum function, or the nature of the roots will be maximum. So the first derivative, remember, our first derivative is over here. Our first derivative is 30. So dA dr is 30 minus 2r. So if you do the second derivative, you're going to have d square a. Second derivative is going to be, is derivative of a constant is 0. that one comes over, so you're just going to have -2, and hence the value is less than 0. As you can see, -2 is less than 0. We therefore say the function has a maximum. Okay, so this is what was required for you to be able to answer the question. That brings me to question number 9. Of course, you also have the advantage of pausing and rewinding if it is that I'm moving too fast for you. You have a question 3 tan x is equal to -2 cos x, and you're supposed to show that it can be written in this form. Well, I'm going to take a longer road here. Remember that tangent can be written as sine x over cos x. All right, that will be tan x there, and it should equal to -2 cos x. Right, in any case, this is 3 sine x over cos x equals to -2 cos x. Right, so this is going to be 3 sine x equals to -2 cos x. So we're going to multiply that with cos x. So that gives me 3 sine x is equal to -2 cos square x, cos x times cos x. All right, so what I'm also expecting from you is to know that the basic, let's use x there, the basic Pythagorean square identity, sine square x plus cos square x is equal to 0. So you can see that from my given, everything should be given in terms of sine square x. So wherever cos square x, I'm going to try to replace it with sine square x. So that means I'm going to make cos square x the subject of the formula. Cos square x should be, in fact, this is wrong, it should equal to 1. So just a little mistake, sine square x plus cos square x should always equal to 1. Okay, so moving a bit too fast there, Mr. Max. Please do follow. So if you make cos square x the subject of the formula, it's 1 minus sine square x. All right, so that means this 1 minus sine square x is going to be replaced, or replacing this cos square x over here. So I'm going to have 3 sine x equals to -2. Now I have got 1 minus sine square x. Okay, all right, so let me just add a paper here, because insert a page, because I might be running out of space to work at that problem. Okay, so let's try to see what I have. I have 3 sine x equals to, so I have got 3 sine x is equal to -2, and I have 1 minus sine square x. Of course, you can multiply this out, so this is going to be a negative times a negative, that's 2 sine square x, and a negative times that is -2, and you have 3 sine x. So 0 over here, so I have 2 sine square x minus 3 sine x minus 2. Of course, this is what we were required to prove. If I just go back to that question, we're supposed to prove 2 sine square x minus 3 sine x minus 2 is equal to 0. Okay, and of course, we have just proven that required to prove. Good. So I think the next step they'll ask us to solve that equation. That is part B. Now they're saying solve the equation, but you see they leave the equation like it was in its original form. So we're going to use what they are saying should be given to in that form. So I'm going to have 2 sine square x minus 3 sine x minus 2 equals to 0. This is what I'm going to solve. And the domain is given from 0 radians to 2 pi radians, so in degrees it's 0 degrees, 360 degrees. Please make sure that you know. I'm going to say let sine x be replaced by the letter k. So I'll have 2k squared minus 3k over here minus 2, because this becomes a quadratic equation that I can solve. Again, two numbers multiply together to give you -4. That is, the two numbers multiply together to give you -4, and you add them, they give you -3. So the numbers have to be 4 and 1, and 4 being the -1. Okay, -4 times 1 is -4, and -4 plus 1 is -3. So that means 2k squared. So I'm going to do that middle term is coming now minus 4k plus k. Okay, these are being the coefficients of that k there. All right, just I'm solving this by factorizing. Of course, you can use the quadratic equation formula. 2k outside, k minus 2, and then plus 1, and k minus 2. Again, as I said, you can use the formula in order for you to solve that. And the formula ordinarily is also given to you in the formula sheet at the bottom of the question paper. All right. If two things multiply to give you 0, it implies that one or the other should equal to 0. So 2k plus 1 is equal to 0, or k minus 2 is equal to 0. So here k is equal to 2, and here k will equal to -1/2. Okay, taking that 1 over and dividing it by 2. But our k is supposed to be sine x. So I'm going to bring back our sine x for that. So this is sine x is equal to -1/2, or sine x is equal to 2. Well, this one is not valid because the sine of a whole number doesn't exist. Remember, the sine ratio is the opposite over the hypotenuse, and 2 is definitely not going to work. Right, so we know our domain is from 0 to 2 pi radians. So if you quickly have to do the cast diagram, all right, we know that the sign is positive in the first as well as in the second quadrant. So we're going to find our acute basic angle. So I'm going to call it beta. So that is going to be the inverse sine of 1/2. Remember, here must be positive. And if I'm looking for the solutions in the third quadrant and in the fourth quadrant, in the third quadrant it will be pi plus beta. In this fourth quadrant it will be 2 pi minus beta. Anyway, if you know the inverse sine of 1/2, okay, that gives you 30 degrees, or 30 degrees is pi upon 6. Of course, you can always work it out by saying the inverse sine, so that shift inverse sine of 1 over 2, and you hit enter and you get pi over 6. So it's pi over 6. So our angle is, our acute basic angle is pi over 6, but that's not the required angle. So the required angle will be in the third quadrant because it's still within the domain. Then we're going to have angle x would be pi plus pi over 6, which obviously if you add them gives you 7 pi over 6. All right, you can actually go ahead and you can say, okay, the answer plus pi gives you pi over 7 pi over 6. You can actually hit to three significant figures, 3.67, okay, or you can say 3.67 radians. All right, another solution, and I'm just going to write it under here because I don't have much space, is going to be in the fourth quadrant, and you can see that this is still within our domain. The value of x is going to be 2 pi minus our reference angle. Okay, so that's 12 minus 1, so that gives you 11 over 6 pi. It's 11 o'clock, that's about 330 degrees, or, but the answer must be in radians. Well, we're going to have 11 over 6 pi, and perhaps you can change it to 5.76. All right, 5.76 radians. All right, so these are the required solution to this, to solving this angle. Okay, also always be aware of your domain. All right, so that brings me to question number 10. So question number 10, what they did is they gave you a curve here, and it's a sine curve. It's a sine of y equals to a sine bx plus c. The nice thing of some of these things is your plus c is indicating the y-intercept, because remember the normal sine function will start at 0. So our value of c, we can clearly determine our value of c is nothing but 1. Okay, and then our a is our amplitude. Now here's the thing about the amplitude. Of course you can see it from there, but I'm going to write it down. So the amplitude is calculated by taking the absolute value of the maximum minus the minimum, and you're going to divide by 2. So the maximum here, as you can see, it's 3, and the minimum here you can see is -1, and you're going to divide that answer by 2. So of course you're going to have 4 divided by 2, and 4 divided by 2 will give you 2. Therefore a is equal to 2. Okay, right, so let me just write down what I have now. So here's another thing. Your value of b, obviously your value of b is obviously your influence with regard to the period. And when you look at the period, you would see that a sine curve is normally a complete curve. Like if you were to do the sine curve, for example, the graph of the sine graph will be something like so, and then this will be one obviously oscillate between the sine curve will be. I just want to see if I can draw it there without making too much of a mistake. All right. Oh my goodness, it is horrible indeed. So the sine curve, so our 180 will be somewhere over here. So the sine curve itself is going to be something that goes in this particular way. All right. So, but that's a complete curve in every 360 degrees. So that b tells you how many of these curves will you have. But in this particular case, you can see that you have a complete curve after every 3 of them. Okay, you see that's 3 of them that are fitting in there. So our b value is therefore equal to 3. So b is equal to 3, and we already determined that our c value is equal to 1. Okay, all of this is answering the question because they say find the value. The integers, it means they must be positive or negative whole numbers. All right, so the second part, they say write down the period of the curve. Well, the period of the curve, remember, the sine function repeats itself after every 360 degrees. B, which is affecting that, is equal to 3. So the period here is nothing but 120 degrees. Can you see that? So after every 120 degrees, you're going to have a complete curve, as you can see evidently from the graph. There's one after 120, another 120 is 240, another 120 is 360. Okay, they say you must find the values, so you use the graph to find the values. Here's a question C that that you should remember, and I hope you have watched the transformation of functions. This is one of the videos I have done, and because we have been talking about what happens when you reflect something on the x-axis. So the function as it's now, our value of a is 2. Just want to see a sine bx. So it's a sine of bx plus c. But our function now completely is our a value is 2, our b value is 3, our c value is 1. In order to have a reflection in the x-axis, and this is a very important thing that you should never forget, okay? You multiply the whole function, I'm just going to say multiply f of x, then you have an idea, okay? Multiply the whole function, in this case multiply f of x, okay, by -1. So you're going to multiply the whole function by -1, okay? So that implies that you're going to have minus, in bracket, that's 2 sine, well, of course, it's 3x plus 1. And if you were now to multiply that function by -1, of course, distributing that negative over here is the first term. It's going to be minus 2 sine 3x, and a negative times that is going to be -1. Very important that you remember this very important fact here. Otherwise, you will not be able to um, solve this question, transformation of functions. Please refer to it. You will see I have done what happens when a function is transformed. There are stretches and there are compressions that are taking place and reflections about the x-axis or the y-axis. All right, so these were the questions on trigonometry that was in last year's paper. And since I've been doing this week the work with my grade 12s on trigonometry, I felt that it was necessary for me to explain the same concept. Do stay tuned. I'll be doing vectors soon, and I will also be solving the questions on vectors from the question paper that was written last year. There's a question on vectors in order for you just to keep up with the work as it as it um, as it hits you. All right. Thank you very much.